Excellent. Well, thanks again for joining me for this webcast. So today we're going to talk about what a PLC is. I'm sure everybody on this webcast has some knowledge of PLCs and what they are, but we'll describe it just a little bit more in case there are people new to industrial equipment on the webcast. We'll talk about what the current process is for the documentation of these PLCs that are inside of the control box of your industrial equipment typically. And this is based on what I've seen in interviewing our customers in the past few months. Then I'm going to give you a proposal for how to improve this manual documentation process. And we can discuss if you like what you see for this proposal for improvement, you can have us come in and we can talk to your people about it. So first of all, what is a PLC? Well, obviously it's Programmable Logic Controller. And they've been around for quite a long time, almost 50 years now, believe it or not. Back in the 60s, General Motors thought that it would be a good idea to replace some of the low voltage industrial relays and control circuit stuff and make it, rather than wiring it all in a control box, have a solid state type of device that can be programmed from the outside. So a PLC is a small industrial computer. Works well in a nice closed box. You connect to it using some sort of connection to an Ethernet or a COM link. And it really does clean up your control box and give you faster access to your applications. And it's also easier to program and duplicate circuits if you're going to have a machine, multiple machines doing the same thing, right? So that's what a PLC is. Now, there are lots of companies out there that make PLCs. You probably use a PLC or have in the past from one of these vendors that you see right here. Now, the cool news about that is that they're standard and you can buy them, and there's lots and lots and lots of varieties of them. The bad thing is that you can pick from whoever you want, and there's lots and lots of varieties of them with lots of part numbers. And there's lots of information that describes a PLC. There's lots of I/O. You assign address information. There are different types of PLCs. For example, you have brick-style PLCs that have a predetermined number of inputs and outputs. If you take a look at that PLC on the bottom of the PowerPoint here, you take a look at all the screw terminals there. There's a lot of connections there. And each one of those connections is doing a different thing for input and output. One might be controlling a sensor. One might be displaying whether to turn a light on or off on the front of a cabinet. Obviously, there's going to be some power connected to this as well. There might be some connection to a network, so you might have an off-site computer that's monitoring a certain process. So there's all sorts of different connection information that you have to describe, especially when you're going to create documentation for these items. So first of all, there's a brick-style PLC. Then there's rack-style PLCs, like this one that you see right here in this box. Looks like an Allen Bradley to me. And you can see that we have multiple modules inside of a rack-style PLC. So you can have different combinations of equipment, and it becomes quite powerful. And look at all the wires going into that thing, for crying out loud. There's hundreds of wires that are doing different things. So this is an example of a very complex system. And imagine documenting this. So the current documentation process that I see our customers going through right now, it doesn't have to be in this order, but this is what people do. They'll typically start early off. A controls engineer or an electrical engineer will select the PLC that satisfies the requirements of their machine. We'll talk about, for example, a robotic handling equipment type of piece of machinery that is, well, let me show you on my screen right here. I will open up an illustration here of a robotic package handling system. And this is a 2D illustration of it showing the major locations. That you notice that I have 3 rectangles on my screen representing 3 different control boxes for this setup. One for the main electrical closet, one for controlling the conveyors, and one for controlling the pallet dispenser operation. And there's a PLC in each one of these things that help control the amount of wiring and logic that's happening. So documenting this is typically done by creating a drawing showing a PLC and its I/O information. As you see right here, we have a Schneider Electric PLC with all the ports, terminals, and the wires, control and the power wire, as well as a terminal strip information and the functions that that wire is connecting to. Okay. Even cables are being called out here in addition to wires, that W11 and W12. So this is a document describing one piece of a PLC. It's not even the whole PLC because there's a lot more information on it. If I go to, I have multiple pages of PLC information here, as you can see. Okay. So somebody needs to create this document to tell the electrical technician how to install it. But you also need to have a PLC program that uses some kind of proprietary software to tell the PLC how to work, how it's controlled, right? So that combination of information is used to create that drawing that you saw me open up previously. There's lots of other things that go into that, though. I mean, it's not just the program and creating the drawing. If that's a multi-sheet drawing, you have wires that cross-reference from one page to another. We want to also add the information on the drawing for what the function of each terminal is achieving. For example, for that robotic package handler, we might want to say that port I8 is controlling the emergency stop switch. And that must be showed, for clarity's sake on the drawing, because what happens if this piece of equipment goes down in the middle of the night? You need to take out that drawing package and see what is connected to what. So all that information needs to be called out clearly on a proper drawing. As you can imagine, this is an arduous process, taking days, weeks, or months to put together depending on the complexity of the project. So let me show you a proposal for improving this process using SolidWorks Electrical, our new application for electrical design. So let me just turn off those sketches here. And I'm going to zoom in to the 3D model of that same exact document set that we were just looking at. And if you take a look at this, we actually have a PLC, brick-style PLC, Schneider Electric, inside of a control box already with a number of contactors and switches on top, up on the DIN rail with some conduit to route wires through. And you can see there's obviously no wires in here yet. We don't even have all the rest of our components placed yet that we need. So we can have a terminal strip with circuit breakers and those types of things. And a cable running to the control of the motors in our system. That's what I had loaded up previously, and this other configuration inside of SolidWorks was the full system here. So I've already done this earlier, and that's where we want to go with our electrical cabinet design. But I'm going to start from a half-clean sheet of paper here with this information here. And I'm going to introduce you to SolidWorks Electrical, the schematic aspect of it. So this is a standalone application, DWG-based, powered by DraftSite, if you will, for handling the electrical documentation. So we have the same package loaded up here. We have this project called PLC Webcast, and I have several folders here. I have 2 books, one for the packaging line system and one for the pallet dispenser system. That way we can kind of group things together. We also have folders here for block diagram showing the interconnectivity of the prox sensors and lights and things like that, and the terminal strips and the motors. But we also have our full schematic diagrams in here as well. We have our multi-line schematic. As you can see, we have our look at the properties of all this right here, our magnetothermal circuit breaker, normally open contact, terminal strip, and motor. And going from the terminal strip, we have some cables. So let's just go ahead and add some more information very quickly here. And then we'll add a new PLC to connect all of this to. So I have, I want to go ahead and drop in some wires. So I'm just going to draw all these wires all at once. So I'm going to draw my three-phase power right here. And then I'm going to copy and paste some information. I'm just going to copy this circuit breaker, copy that normally open contact, and copy this motor down. I'm just using Control-C and Control-V. I mean, it's just simple Windows copy and paste here. And it's automatically assigned a new reference number to that item. And I really want to make that call be called out as Q4, because I had on my block diagram earlier called that out, so I'm just referencing that original item. Same thing for this one. I'm going to call that K4 for contact 4. And finally, the motor is at M5, which it guessed right. Let's drop in a quick terminal strip here and tell it to be part of terminal strip 1. And you see it automatically increments all the terminal numbers here. Okay, so that's all good there. And I need to drop in a PLC. Now, I already have a PLC drawing, but I'm going to create one from scratch here for you to show you how I would go about creating this from our system. And I'm going to insert a new PLC in our component tree. So this is the component tree in SolidWorks Electrical. And you just tell it where you want it to be. So these cabinets here are locations, virtual locations, which are really closely related to subassemblies in 3D mechanical land. So I'm going to go ahead and insert a PLC inside of this door location. And I'm just going to call out a PLC mark. So I can give it a root number. By default, it wants to go to N, but I could call out PLC as the root of the mark number that it's going to create. And it sees 2 is the next available mark number. Then I have a tab for the manufacturer of parts. And this is really pretty cool because I can search through a database of PLCs that the system comes with. So if you look at this, I can go to my manufacturer list and go to Automation Direct here and see that there are PLCs in here. And they all have I/O information already stored as part of the catalog. So I have this really super-duper catalog here, and I can go ahead and select different items here. There's Schneider Electric, here's Siemens, where's Omron? There's Omron. So you can see there's all sorts of different PLCs in here. And if there isn't one in here, you can create one very easily. So it's a really great system for managing this. I'm going to choose a Schneider Electric, and there's quite a few Schneider Electric parts in here, but I'm going to type in part of my part number. I want an SR3B261B. And it finds the B and the BD. And as you can see, if I double-click this to make the screen just a little bit bigger, you'll see it has all the circuits in here. Quite a few, I might add. And if I look at this, I can look at the properties of this part. See the part number, manufacturer, description, even the 3D part and the 2D footprint that should be called out, a connection label. So all the symbol information can also be connected to this. And all the circuits are in here, obviously. So you would create these circuits manually if you had a PLC that you didn't like. It's very easy to add new circuits. But I'm going to use this existing one. And I'll say select and OK. So there's my new PLC2 component. And I could go ahead and edit that PLC or insert it into a new drawing. So I'm going to create a new drawing here. So I'll just say new scheme. Go right here. I have a blank sheet of paper now. And I could go to that PLC right here and say insert the PLC. You can see that it's giving you a very basic preview of a rack. And it's also got this diagonal line at the bottom showing me that we're breaking the PLC because we're not going to be able to fit it all in one page. I can switch the orientation of that around here. So you can see where the terminals would be. Okay, I can make this just a tad bigger here. And I can tell it how many I want to use. So I might want to go all the way up to 9 here. So I have my power coming in. And the first 9 terminals here for my input. And I'm going to select the first addresses here and assign a mnemonic to it. So I automatically assign that based on rules that are built into my system. And then I can decide which macros I should use. So I can actually select a macro from a list of common circuits that I like to use, like so. I don't need to do it to all of them. Maybe the first 3 I'm going to have no macro, and maybe the last 2 I'm going to have a different macro, like that. Now when I place these on here, look what it's going to do. It's going to place all of the wires and circuits that connect to that PLC on here. As you can see, it's called it out with the right part number, mark number, and manufacturer. All the I/O and mnemonic address is built right into the symbol. And it's even added new terminals to a terminal strip and called out new push buttons and sensors here because that was part of that macro that I had added. You could very easily draw in your own geometry here as well. So let me finish off the wiring just a little bit. So I can do something like that. I could stretch these 2 wires over to the other wire just like that, and it forms connections automatically to them. So that's pretty cool, isn't it? And I could continue drawing my PLC because I only drew part of it. But let's go in and edit the PLC before I do that. I can right-click right on the symbol inside of SolidWorks Electrical and choose Edit PLC. It shows me this is PLC2 that I'm working on. And I can manage the inputs and outputs. I can generate the rest of my drawing package from this window. If this was a rack-based PLC, I could add different modules or interfaces to this PLC. It would search the catalog for items that would be part of it. So I could just, hit add here. Now I've added a module to that PLC, and you can have as many as you want, as many as that PLC that would support it, I would imagine. Back over here, I can establish descriptive information here. So if I double-click this, I can actually give it the English description for emergency stop. And you notice you can even have multiple languages in here. It's very often that you have documentation packages that need to be in other languages nowadays. So if I went to Google Translate or something here, go into my other window, and I forget what emergency stop would be in English or in French. My French name, I'm quite embarrassed to say I can't remember how to do this. So there's an emergency switch here, and I can switch it to French right here. Copy, paste. And then Spanish, there it is. El interrupto de emergencia. So I have that descriptive information in all 3 languages now for that PLC, and I can print out a documentation package with each language built in. I'm not going to do that for all of them right now, but I could actually store that with the PLC in a spreadsheet as well and bring that in. So I'm going to go ahead and add my, this is going to be the motor start, motor stop. Okay. So pretty easy to do that. And the reason why I did it here is because now it's going to be available right over here. See all that information? It's right in the symbol for that PLC. I'll continue my PLC insertion. I'm going to insert a new page, and I'm going to insert the rest of my PLC to here. So if I say insert PLC, it knows where I left off automatically. I'll have it insert the default, and then that's the end of it right here. Yeah, I can actually put it all in one page like that if I want to. And I didn't have it insert macros in this case, but I'm going to go ahead and draw wires manually because it's not that hard. So there's a wire, and I'll just insert a few like so. And it knows how to trim them against these terminals automatically. And I can go ahead and drop in wires like this. Then I can choose my control wire and have it overlap, something like that. You can actually insert jumper symbols here. So I want to jump across a wire here. Let me slide that over here. That way it looks a little nicer as it's jumping over. There you are. So I already have a bunch of the stuff done, so I'm just going to close these drawings out. I'm actually going to delete those two sheets that I've just added because I already, earlier today created these 3 drawings that I want to use that I spent my few minutes this morning working on. And the reason why I'm going back to them here is that I haven't completed the wiring yet. If you look at this, I have wires that aren't connecting to anything. Okay, so let me insert a motor control circuit, and I'm going to go in and just reuse one from one of these macros that I've created earlier. So you can have company standard circuits for motor start and stop and all sorts of different things. I'm going to establish a relationship. I'm going to go to the symbol properties and make this Q6, and I'm going to make this transformer 1. Based from my single line diagram that I showed you earlier. And I want these wires to connect somewhere. Right now they're not. So I just need to organize my wires, and I can tile my windows up like this. So on this page, page 5 to page 7, I want to connect my wires. So I just say I want a wire to go from here to here. And I want this wire to go from here to here. And it will only let me select wires that make sense to connect. Really pretty cool. And now it's giving me the reference here saying that this wire is going to page 7, row 1. And if I go to page 7, row 1, it's telling me that's coming from page 5, row 11. Fantastic, isn't it? I already have the references going to the other pages of PLC. Now, because we have that, now this is all great that we have this information, but what if you want to import some information to connect to this? So you could actually bring in the information from your PLC program like RS Logix, or if you're using Automation Direct, click control software and import the description and I/O information. So that would appear automatically on your drawing. And that's actually pretty easy to do. It's pretty much a copy and paste from the application. So if I went back to my PLC here, and let me go to the PLC tab here under Inputs and Outputs, I could actually see that information here. Go to this data grid. You can see all my descriptive information here, but let me select all of them. And I could actually just copy and paste from Excel all the information, the associated address, description information, all from here. And that would be achieved by, I'm not an expert at this application, but if you'll indulge me, I have picked Automation Direct's PLC software in this case. And I could start a new project here and build my ladder logic for designing the PLC as far as what the functions are going to be, not necessarily the drawing of it. But I'm going to pick this. It's very much like an Excel spreadsheet where I'm going to say I want to normally open contact at a certain address. Actually, I can pick it right from this list right here, depending on which PLC I'm using. And the cool thing is you can copy and paste in this application. So normally closed, I'll throw one of those in here. So I'm just throwing this in. I don't have a good example for this right now. I just downloaded the software this morning. But what you do is you export the information out as a CSV file. So I'll just throw that on my desktop. And obviously, I would save this program in my vault along with the rest of my design. So I would go to my vault and go into my projects and store this program for that particular project for the project that I'm working on under the electrical systems, perhaps. Okay. Then I go back to SolidWorks Electrical. And look, I already have my CSV file here, and all that information I could copy and paste from there into SolidWorks Electrical in the data grid. Just like that. And that's all going to show up on the PLC that I added. So I have all that, and that's going to show up on my drawing, and it's going to look great. And I also need to have wire numbers that have a label on it and everything else. So if I look at my reports inside of the system, I have a list of cables and a list of wires. Let me go ahead and add that cable or wire. So I'll say I want my wiring lists here. List of cable cores. There's no length right now, but they know what goes to what. Origin X4 goes to destination M6, terminal U. No wire number, though, as you can see. So let's address these items. What if you could generate the wire numbers automatically, like you see on this slide right here? You can. Okay. So all you do is you go to the process wire numbers, and you establish rules for which wire gets which wire number. So here's N10. Then here's my control wire 2, 3, 4, 5, 6, 7, 8. And there you are. So automatically done for the entire project, not just this sheet, but all the sheets. That's a massive amount of work done. Plus, if I go back to my slideshow here, now that you have all the wire numbers, you're ready to actually tag and print these wire numbers. So you have that label making machine. A lot of people use a Brady label printing machine for a wire, and you have all the information here in a report. So if I go back to SolidWorks Electrical, I have reports ready to go. There's my wire number. The length isn't on here yet, but I could actually export that as an Excel file for my list of cables, and I'll just go ahead and select them all, and it'll actually output Excel files that could be brought into the wire labeling software. So I'll just throw it on the vault for that particular project, of course. under the electrical information. And you can see there it is generating all of the reports for me. All centrally available in the vault. So now that somebody on the shop floor who's responsible for this, once it's an approved document, the EPDM system can be used to approve that. So let's address the wiring information now. Right now, we don't have any documentation of how to actually show the wires like you see on this page. What if you could actually lay this stuff out and actually route my wires in SolidWorks 3D? You can. And it's, because we have the same PLC showing up, here as it was in the schematic, I could actually go into the chassis of here, and there's N1 PLC. And if I select it from here, you can see that it's already associated with that component, because this is the list of parts that the schematic called out for. If I wanted to add more parts, let me hide the ones that haven't been inserted yet, just so you can see what it would look like. If I look at my chassis, I have this K1 through K6 that haven't been placed yet, along with a transformer. So let's go ahead and insert those just to show you what it would do. I could change the order of them if I wanted, place the part wherever I want it to be, and it would go right in. All right, so my directory is, I changed my directory earlier, that's why I'm getting that message. However, let's go ahead and finish up the wiring of what I have here so far. I'm going to just say route wires. You can do it in a preview type of style. So I'm going to select the PLC to wire. I can select them all. It'll only take a minute, under a minute to do it. But since we're on a webcast, I'll just pick one part. And it's connecting any of the terminals that are on that PLC to wherever they need to go as the schematic had called it out. And there they are. That's everything that was connected from the PLC was automatically drawn in. Simply amazing. Then you could actually make a drawing of what you see right here. So I'll just tell it to create a brand new drawing. Tell it which view that I want to pick up on. And maybe I just want a B-size piece of paper here. And I'll just bring in a particular view here. Now, of course, I want that to be cropped because it's I don't need a view that big. So did you know we have a crop view tool inside of SolidWorks in drawing mode? All you need to do is draw a rectangle around what you want to make a view of, like that. And then under View Layout, you could crop the view. Then I can change the scale of this view to whatever I see fit, so I'll make it to 1:5 or something. See what that looks like. Looks like it might work. Yeah. And look at that. We have all of our wires in here. We have the placement of our components. I could actually go as far as having it create the mark information by calling out balloons. So I'll throw a balloon on using the, not the item number, but the component reference. I'll just have it throw underlines on here. So if I pick that part, it's going to show me that's N1, that's F1, Q5. So all that is readily available for us, and I could have auto-ballooned the whole thing at once too, of course. Now all that information is ready to go, and I could actually add that as part of my document set. Let me just turn off the sheet format I don't really need to see this for what I'm going to do next. It's going to save my drawing as a normal drawing file. I'll just overwrite the one I had there. And then I can just add it to my document stack. So that way when I do a print of my project, it will be saved right along with it. So I'll do that now. I'll just tell it to create a project drawing. And it's actually taking that from SolidWorks drafting environment and sticking it in the electrical project, which you can actually see. Inside of here. Pretty cool, huh? Of course, you could just print that all in one fell swoop and life would be good. So, to review, our proposal for improvement was to generate the PLC program in your proprietary software, which is what you have to do anyway to program your PLC. Export the I/O and descriptive information using an Excel or CSV file and import that into SolidWorks Electrical. And then you can have different symbols be readily available, or macros as I called them out earlier, to make those drawings automatically. So the obvious benefits here is that there are going to be reduced errors. You're not going to be typing things in twice or forget to connect things up. The wire cross-references are automatically kept up to date as well. Of course, you get the wire numbers and all that. And you have faster design throughput. With the added benefits of wire number generation, wire numbers being tagged and printed, the layout being available in 3D and being able to generate detailed drawings with the marks as well. So definitely schedule a time, call me up. Just go to capinc.com, our information's right there. Give me a call. Or you can come to our CapInc events that we regularly schedule. Next Friday we have in Peabody, Massachusetts, a hands-on test drive for SolidWorks Electrical. I encourage you to attend. Also Westboro, Massachusetts, March 22nd. So usually every other Friday or every third Friday we'll have some type of event at our offices or on the road as well. So I really want to thank you for joining me in for this webcast today. Hope you enjoyed it. And it has been recorded, so don't feel bad if you missed a part of it. You will be able to watch it a little bit later. Okay, thanks again and have a great day.